Hi guys, let's go to our problem statement 25 directly. So code quest 3, problem statement 25. Let's see what we have here. Roger's string permutations assignment. Okay, let's read it. It says finding all possible permutations of a string by backtracking. Okay, so as soon as you listen to this word or see this word backtracking, just remember the question is talking about recursion. Okay, so we have to solve this using recursion. That is our first approach that we have in our mind, right? We know that. Now let's read the problem statement. Roger, a bright computer science student, has recently started his journey in algorithmic problem solving under the mentorship of Professor Smith. Okay, so Smith assigns Roger a problem to test his understanding of backtracking algorithms. Okay, so the professor wants to test Roger's backtracking skills, how he solves those problems. Okay, let's see the problem given to Roger. Given an array of distinct strings, you need to write a function to find all possible permutations of the given strings in a lexicographically increasing order. So, what do you mean by lexicographically increasing order? That means just like our dictionary. Okay, the letters start with A, then B, then C, and keep on going like this. The alphabetical order. Okay, so similarly, if I just say apple will come first, then if I say asterisk, asterisk will come after that. Okay, APP, then AS, something like that. Okay, so it will be lexicographical order. Got it? And they have given something here. The length of the string should be between 1 to 6. Okay, and you can see here they have said that each element of the string will be actually a lowercase English letter. Okay, fine. Now this is the requirement. Now after that, see the output. The function should return a 2D vector containing all possible permutations. Okay. Each inner vector represents a single permutation of the strings. So it will be difficult to understand the output like this. Let's see if we have any sample input and output. Okay. So yeah, we have something here. So see here, the function signature is something like this. Find permutations. And then it says it is a 2D vector. See, vector of strings. Okay, and this find permutation, this takes a vector of strings as letters, and then it will return you the output. The output will be all the permutations. Okay, so here you have you can see the sample input and output. So ABC, this is the input, which is an array or vector, you can say dynamic array. Both the same, right? So vector of strings, result 1 equal to, we call the function and pass this input, which is ABC. Then see the output. ABC, ACB, BAC, BCA, CAB, and then we have CBA. Okay. So these are all the permutations of the letters given here, right? And similarly, if you see AB, then it will be AB and BA, right? So we have figured it out, right? And the last one, we have only one element, so it will be the single element only. Fine. And here you can see they have mentioned Roger should implement the find permutations function using a backtracking algorithm to find all possible permutations of the given array of distinct strings. Okay, fine. So that's our target. And you see here the length is given like this, 1 to 6, and then each letter should be of one character. Okay, so all characters of each string in letters are unique. Okay, there will be no repetition of the characters, so we can be sure of that. These things are given. Now let's try to understand. Let us take this input only and try to understand how we can solve this. I'm going to my board and let's see what we have. So right now we have been given this string called ABC. Okay, and in the output, if I'm not wrong, they've given ABC, they've given ACB, then they have given BAC, then BCA, then they have given CBA, then they have given CAB. Okay, so what are they actually doing here? If you try to analyze, we are actually taking boxes like this. Okay, and we are trying to place the elements in this box. So every element will get a chance. So first what I do, I place A. Okay, let me take two boxes like this first of all. Okay, here also I place A. Fine. Then what are the chances I have? Out of A, B and C, I've already placed A here and A here. Then I have B and C, right? So here first let me place B and C. Then I can give another choice. I can say C and B. Okay, these are the only possible things. Then for the second time, what I do, I have already given A chance. Now I will give B a chance. So here I will say I will place B first. Here also for the second one, I will place B first. Then I am left out with two more options. Either I can say A here and then C, or else I can say C here and then A. Correct? Similarly, for the last one, it will be something like this only. First C, then B and A. Then either it will be C, then A and B. Okay, and they have not told us to focus on the order. Okay, so we can return the answer in any order. Fine, that is the target. So every time you can see here, we are giving a call for either A or B or C, and then we are swapping the other things. Correct? That is what we are doing. Now, here in this case, we have three elements or three single characters. So what will be the maximum value or the number of permutations? If I say number of permutations, it will actually be n factorial. Okay, if the number is n, then n factorial. So it will be, here in this case we have three digits, so it is 3 factorial. Okay, three elements, right? So it is 3 into 2, that is 6. Okay, so therefore you can see here 1, 2, 3, 4, 5 and 6. We got 6 combinations. Correct? So any number we have, it will be actually that number factorial. Okay, so if we have say 4 elements A, B, C, D, then we will have a similar thing like this. It will be 4 factorial. So it will be 4 into 3 into 2. It will be 24 permutations. Okay, fine. Now we have got this. Now let's see how to go about the approach. How will you solve this? Okay, so first what we will do, we will take A, B and C here. Okay, and we will have to play around with the index. Suppose the starting index here is I. Okay, this I is actually the starting index. Now as we said, as we discussed, we have to give opportunity for A, then B, then C. Correct? So let us give opportunities like this. Fine. First I will give an opportunity to A. Then I will give it to B. And then here I will give it to C. Fine. So when I'm giving the opportunity to A, obviously let me change the color. I will just write A. Correct? Then I have the two other things. So I will say ABC. Got it? In this case, I am giving the opportunity to B. So I'll write B first. Then what I will do? I will simply swap B and A together like this. Okay. So what will happen here? A will come here and C will go there. Correct? In this case, what happens? In this case, I'm giving the opportunity to C because A has already got the chance, B has got the chance. Now it's a chance of C, right? So C comes here. Then what I do? For doing that, I will have to swap C with A. Okay. So here we'll get A, then we'll get B. Okay. Just we are swapping them. Now what happens? You can see initially I was at the first index here. Now I will come here actually. Okay, for all the cases I has come, so the index has gone to the next element. Correct? Got it? Now what happens? Now let's take a different color and now let's see. So in this case, A has already got the call. Here also B has already got the call. C has already got the call. Now I have to call for B and C. Correct? Everyone has to get equal chance. So here this will be B's call. This will be C's call. Okay, when it is B's call, I will swap B with B only. So there will be no change. Okay, so it will be A, then B, then C. In this case, it will be C's call, right? See here. So I will swap B and C like this. So what will happen? A and C and B. Got it? Now what happens? I was here in the second element, B. I will come here. Yes, we have to increase the index, right? Then only you can do this. Here also I comes here. Got it? Here in this case, B has already got the call. So I have to make a call for A and C. Correct? This will be A's call. This will be C's call. Now simply, if it is A's call, I will swap A with A only. Correct? So I will say B, A, C. In this case, it is C's call. So I will swap C and A. Make sense? So it will be B, C, A. Got it? Similarly, in this case, it will be already C has got the call. So it will be A's call here and it will be B's call here. Correct? Now you can see, if I take this call, A's call means A will be swapped with A. Okay, so CAB, whatever I have, I will write like this. Correct. Now see what happens. In the next one, it is B's call. So I'll swap A with B. Okay, this will be C, B, A. Got it? Now, as I said, I comes here, right? Everywhere I will be at the last position. Correct? Now, when it is at the last position, I again have to swap the element with itself. Okay, with itself. No other element is present, so I'll swap with itself. So ultimately, we'd get the same answer only. Because I have to complete the loop, I am doing this. Okay, so what I do, I will take a different color and I will just say I'm swapping C with C only. Okay, C with C. Here it will be B with B, C with C, A with A, B with B, and A with A. So ultimately, I get here ABC. This will be ACB. This will be BAC. This will be BCA. This will be CAB, and this will be CBA. Okay, now what happens to I? I goes out of the loop. Here also I goes out of the loop. Same here. Every case I goes out of the loop. Okay. Now when I goes out of the loop, that means we have reached out of the condition. Correct? Then we can simply store this as the answers. This will be our answers, right? This was what we got there earlier, if you remember. So these will be our strings that we need. These are the 6 permutations. Correct? Got it? So we have got our answer. Now, if I say again, in the first case, I was here in this position. Let me take a different color here. Okay, let me take blue and let's see. Okay, in the first case, what happened? I was here. So I gave A a chance. Then I gave B a chance. Then I gave C a chance. Okay, gradually you are keeping on doing. So for A chance, what I do, I will swap A with itself. So ultimately nothing will happen. We get ABC only. Correct. In this case, what happens? I have to give B a chance, right? We saw that. When you give B a chance here, B will be swapped with itself only. So we got ABC. In this case, I have to give C a chance. So B and C are swapped. So I get ACB. Correct. And similarly, we are doing this. But there is a very important catch here, guys. You have to remember this. Okay. So ultimately, we have got this structure from here till here, right? We have got to the answer here. But just try to understand this. When I come from here and get this answer, and again, when I come from here and go back, what am I actually doing? First, I swap, right? I am swapping. If it is a single number, I swap with itself. If there are two numbers, then I swap with the adjacent. I'm doing that. And when I come at the last, I swap itself with itself, doing that. Correct? But when I go back, I am again restoring my original string, right? So that I can get back the different answers. Correct? Here also I am doing this, and again I'm going back. Where am I going back? I'm going back to my original string, right? That means this is called backtracking. Got it? That is where our backtracking is actually happening. What we are doing, whenever we are changing I, then we are again swapping that back to ABC. So I am again changing it back to ABC. Because if I don't do this, see what happens. Let me just show you an example. Okay. Say we have A, B, C, right? First we give the chance to A, then it is ABC, then we give the chance to B, so it will be BAC. Okay, then we give the chance to C, so it will be CBA. Correct? After that, suppose here we are not changing it back to ABC. Now see what happens. Here, if you see, A was given a chance, here B is given a chance, here C is given a chance. Correct? After that, already A got the chance, B got the chance, C got the chance. Now what we do? You give chance to B and C. Here we give chance to A and C. Here we give chance to B and A, right? Because the call for the first has already been done. right? Here A call is complete, B call is complete, C call is complete. Now let's see. Ultimately, just try to understand this. After getting this, say here we get BAC and we get what, this will be B only, this will be C and A, correct? Now imagine I am not backtracking, and if I am not updating it to ABC, what happens? Here only I will be getting the next call, correct? So if I give a C call here, see what happens here. If I give a C call to this one, C comes here, we get A here, and then finally what we get? We get B here, right? So, but what happens here? This is wrong, right? This should have been coming here, correct? This was the last one. What did you get here? Remember that? It was C, then we had B, and then A, then we had C, then we had A, then B, right? This was our last one, right? So this is actually wrong. This is not lexicographical. So if you don't change back to the original one, it will be difficult for you to get the next solution. That's why we need backtracking. Okay. And that is where we are actually swapping. We are actually swapping the index again and changing it to the original string. Then we are going back to the next one. Understood? Okay. Now we have understood about the logic. Let's write down the code now. Okay. And you will be even more familiar with the code when you actually write it, because now you have understood the approach. Okay, so let's go to our IDE and write the code. Okay, so I have already created the file. Let's create our vector. It said vector, right? So for that I have to include my vector here. So let me include this hash include vector. Okay, and it is actually a vector of 2D vector of string, right? Fine. And the name was actually permute, or you can say anything, find permutations. Okay, no problem. Then it will actually take a vector of string. Fine. And I will name it as letters. Let's keep the function name as given in the problem statement so that we don't get confused. Find permutations is the name, right? So let's write it like that only. So find permutations. Fine. Okay. So it takes a vector of strings. Fine. You can also use an array, but in the problem statement they have told us to use vectors, so it becomes very easy to do this. Okay. Now first let us create a vector of answers. Okay. Vector, it will be a 2D vector of string. Okay, and let me name it as answer. Fine. Now initially we start from the first index, so I need int index is equal to 0. Okay. After that we have to create a function called backtrack where we will be actually swapping them, right? So I'm just writing backtrack. Inside that I'm passing my letters, the array or the vector, and then I'm passing my answer. Okay, and then I'm passing my index. Okay, fine. And finally, sorry, this should be backtrack. And after that, let me return my answer. So now we have to write down this base logic for the backtrack. So let us do it. So it will be void backtrack, and inside that it is actually taking a vector of strings, and the name is letters. Okay, and I need to dynamically update the answer, right? So it will be a 2D vector, correct? It is also string. And here I will take my answer as the address. Guys, why am I taking the address? Because I need to update the original one only. If I don't pass the address, then it will actually just take the copy. I want to update my original vector only, okay? And I need the index. There should be a comma. Okay. Now let's write down our logic. So what was the base case? As I said, if my index goes beyond the limit of the length, then I will just get the answer, right? I will just store the answer and return. Fine. So this is our base case. Okay. I'll just say if our index is greater than equal to letters dot size, because it is a vector, I can use the built-in function size, right? I will just say answer dot, in the vectors we have the pushback function. I will just push back our letters. Okay. And then I will return. That's all. I don't have to do anything. After that, now let us go for indexes and try to do the swapping and the backtracking. Okay. So I will just say for int I is equal to 0, I less than letters dot size, I plus plus. I need to swap them, right? So swap what? I need to swap the current index and the ith index. So I will just say swap. I will use the built-in function. I will swap our letters of index and I will swap the letters of I. Correct? We were doing that. If it is in the same index, I was swapping the same element with itself. Got it? After that, what I do? You remember that after we have done this, we have to backtrack. Okay, so for that, I will just call my backtrack function. Here, I will pass my letters. I will pass my answer because I need to store the answer. And then I need to pass the next index. So I will just say index plus 1. Make sense? Because if you see here properly, see here, see this one, you will understand better. Okay, so here if you observe carefully, first we are swapping. Okay, let me take this diagram, otherwise it will be confusing for you. Okay, here you can see, right? First it was I here, then I came here, and then came I here. Correct? So you are just taking I and going to the next indexes. Okay, so next time when I do it, I have to swap for index plus 1. Correct? Because I need to change for the next one. That's what I am doing here. Okay, got it? And after that, what I do? Here comes the main backtracking. Here what we do? As you saw here, we were just returning back the same string again, right? Because it will help me in finding out the next permutations of the string. Correct? We are backtracking. So again, swap back to the original content. So I will just say swap. What you do? You will just say letters of index and letters of I. Okay, we are just swapping it back so that I can go back to ABC again and start from scratch. That's all. So this is all about our backtracking algo. Fine, we have done that. And we have also created our this thing. Now let us create one more function so that we can print the vector. Okay, so I'll simply write like this: void print vector. And if you see in the problem statement, they have given something like this. Let's see here. Yeah, somewhere they have given. Yeah, each inner vector represents a single permutation of the sinks. That means it is a vector of vectors, right? 2D vector. So the inner vector will represent the each element. Okay, so let's see how to do this. We'll just print vector and we'll say it will take a 2D vector, vector of vector, and it will be string. Fine, I don't need this bracket. Then I will just pass the address of our vec. I can just say vec, no problem at all. Okay, and then here I will use the range based for loop. So I will say const auto and I will take the address. I will take inner vector. Okay, this v should be capital and colon in our vector. Okay, got it. So what I am doing, this is a 2D vector. Inside the 2D vector I will have one more vector, so I'm just naming this like this, inner vector. Inside that I want to print the elements. Okay, so first of all let me say cout. I need brackets also, right? I will just say bracket like this. I'll give this bracket like this. Okay, After that, I need one more for loop to iterate over the elements of the inner vector, right? So I will say const string, right? We have string here, and I will just take the address str. This will be the name inside my inner vector, and then I will just print like this. See out. Let me print some double quotes also. So if I want to ignore one double quote, I can take it like this. Okay, str double quote. If I want to ignore one, I will write like this, and okay, done. Fine. And then to go to the next line, I will just say C out. Here I need the closing bracket. Done. And after this, I will just say C out. Next line or endl. Fine. So we have also created the print vector here. Now let's create our vector in the main function, and let's try to call this function. Okay. It is a vector of string, right? Fine. The name was input1 is equal to, it was actually ABC, correct? We had A, comma B, comma C. Yes. So we need a 2D vector to store the result. Let us say result1 is equal to, we'll call the find permutations function, and here we'll pass our input1, and then let us call this print vector function. Okay. So I'll just say print vector, and I will pass my result1. Okay. Got it. So let's run this and check. Okay, so we are getting something different, not the desired output. Let's see what is wrong here in the code. Okay, let's try to analyze the code. Okay, we have our vector letters, then we have our answer vector, then we have the index. The base case was if index is greater than equal to size, answer dot push back our letters and return. Fine, this was our base case. Now, okay, guys, you can see one thing we have done wrong. Okay, yeah. We were swapping with the current index. If you remember here, we were swapping. If it is the current index, I said I will swap A with itself, correct? If it is in B, then I will swap with itself. So here if I write 0, this is not gonna work. Okay, just see here, I should not be writing 0 here, I should be writing index. Okay, that was the actual thing that I did wrong here. Now if we run this, let's see what we get. Yes, see here guys, we're getting ABC, ACB, BAC, BCA, CBA and CAB. Suppose if I have only A and B, let's see what we get. We should be getting AB and BA. Let's run this and check. Yes, we're getting that correctly. And suppose if we're having only A, it should return us only A. Let me run this and check. Yes, we're getting exactly like this. So let's see the problem statement output and try to understand. See, ABC, we got ABC, ACB, all 6. For 2, we get 2 factorial, this is 2 only. And for 1, we get 1 factorial, that is 1 only. Okay, we're getting the outputs. Fine. Now let's do one more thing. We can simply put a comma here so that we can get a defined output properly. Okay, let me give a comma here and a space here. Let's run this now and see. Let me take, say, B, comma, C again. Let's run this now and see. Yeah, we're getting a comma separated value like this. Okay, ABC, ACB, BAC, BCA, CBA, and CAB. But I hope you understood what I did here, right? I was actually doing for 0, so it was not working fine. So what I have to do, I have to do it from the index because I will be at the current part. So I have to swap with itself, then with the next one, then with the next one. Okay. First A with A, then A with B, then A with C. Okay. That is what we did, right? Correct. So this is it, guys. This is about the problem statement number 25. I hope you have understood this. Thank you for watching, and then see you in the next problem statement. Thank you and bye bye.